In this video, I'd like to talk about graphing quadratics when they're in standard form. So remember that standard form for just some general quadratic function is ax squared plus bx plus c. And there's many ways to approach this, but probably the most straightforward method would be to transform this to vertex form, which, by the way, looks something like this. Let's use a different letter, d times x minus h squared plus k, where the vertex is at h comma k. So if we transform this to vertex form, then we can first plot the vertex and then just plot some value on the left or right of that and use symmetry to find a third point. And to transform this to vertex form, notice that we have a perfect square in this vertex form. And to get this, we will have to complete the square. So let's start with our equation. Let me just make a little bit more room here. We have y equals 2x squared minus 8x plus 3. And we want to complete the square. So we want to transform this to some binomial, let's say x plus a squared. And just so that we can compare it to the formula for this, let me write it out. So if you were to multiply x plus a times x plus a, and simplify it, you would get x squared plus 2ax plus a squared. So we want to transform this quadratic into some perfect square plus or minus some number. And to do that, what I want to do is first isolate the x terms. And usually when we complete the square, the coefficient on x squared should be 1. And right now it's a 2. So what I'm going to do is I'm going to factor that 2 out. And I'm going to leave these terms grouped together. So I'd have just x squared minus 4x, and I'm going to leave a space because I'm going to have to add a number so that I can complete the square. And then I have plus 3 on the outside. Now from here I have to determine what number do I have to add to turn this into a perfect square. Well, if we look at our formula and compare the coefficient on x, I can figure out my a value. So in the formula, twice a is the coefficient on x. And in our case, inside this parentheses, the coefficient on x is negative 4. So 2a equals minus 4, which means that a is just negative 2, which means that the number we have to add to each side to transform this to a perfect square is a squared. And when you square negative 2, you get positive 4. So we have to add 4 on the inside here to change this into a perfect square. And then this expression here will become x minus or plus a, and a is negative 2, so it becomes x minus 2 squared. But you want to be careful here because we added 4 on the inside of this parentheses. But really, this set of parentheses is multiplied by 2. So we didn't just add 4, we really added 2 times 4. And so 2 times 4 is 8, so we added 8 to this equation. And we can't just add 8 without changing the value of the equation and essentially giving us a new equation. So the only way to balance this out is we also would have to subtract 8 on the outside. So you want to be careful. When you're completing the square and your coefficient on x squared is not 1, you'll factor it out and then complete the square as normally for this inside quadratic expression. But when you add your number, you just also have to remember that that number is multiplied by whatever you factored out. So from here, we know that the 2 is just going to carry down, and we have plus 3 minus 8, which is minus 5. And if you want to prove to yourself that this method works, I encourage you to pause the video and just multiply all this out and show that you do end up with this original quadratic expression. So from here, we now have vertex form. And remember, the vertex, once it's written with this perfect square expression, the x value of the vertex is the x value that makes this first expression, this first term, equal to 0. And if you put 2 in here, 2 minus 2 is 0, and 0 times anything is 0. So 2 is the x value of the vertex. And when you do plug in 2 here, this whole term would go away and you just get negative 5. So 2 minus 5 is our vertex. So we can plot that point. So now let's go over to our graph. And at 2, -5, right here, we're going to have our vertex. And what's nice about knowing the vertex is that the quadratic graph is going to be symmetric about this x value of the vertex. So you can even draw in this dashed line here. We call this the axis of symmetry. This is when x equals 2. So about this line, it's going to be a mirror image on either side. And at this point, you have a lot of different options. If you want to be really precise, you could figure out the x-intercepts. So we could set our equation equal to 0, because remember this is when y equals 0 along this line, and then solve for those points. Or if you want to go for a slightly faster, maybe less precise method, or if you're using the Khan Academy graphing exercise, in that case, you don't have to find those exact values. If you just find another point or two, the grapher will automatically fill it in. But let's say we want to be really precise and do this by hand. So we're going to set this equal to 0 to find that intercept. So we'll set y equals 0, and y is equal to this equation up here, 2 times x minus 2 squared minus 5. And I'm going to solve for the squared term. So I'm going to add 5 to the other side and then divide by 2. So 5 is 2 times x minus 2 squared, and then divide everything by 2. Let me just make a little more room. So I have 5 halves equals x minus 2 squared. And now that this squared expression, this perfect square, has been isolated, I'm going to take a square root of each side. So square rooting a squared expression, those will cancel out, and you just get x minus 2. And because there are two solutions, we have to put plus or minus to account for that. And we have the square root of 5 over 2, and then we can add 2 to the other side. So we get x is 2 plus or minus root 5 over 2. Now, the only issue with this method is that at this point, we'd have to put this into a calculator to get an exact, or a rough approximation, I should say, of this irrational number. So you're not going to be able to graph this perfectly, but you can at least get a general idea. And once you put this into the calculator, you'll see that it's approximately 2 plus or minus 1.58. And you do have to round that because it is an irrational number. And so when we add 1.58 to 2, our solution will be 3.58, or I should say approximately. And when we subtract it, the difference between 2 and 1.58 would be 0.42. So we could now plot both those points. And I'll go back to green here. So 0.42. Remember, these are just the intercepts. So we have that point about right there. And at 3.58, let's say about right there. And if you really want to be precise with this, you can also figure out the y-intercept. So that's when x equals 0. So if you plug x equals 0 into your equation here, so just ignore the part where we set y equal to 0, then you get y equals 2 times 0 minus 2, or just minus 2 squared minus 5. So this is 4 times 2, which is 8, minus 5, which is 3. So we go through at 0, 3, and really we can use another point because now we can use symmetry. So notice that it's a mirror image on either side of this line where x is 2 at our vertex. So when we plugged in 0, which was 2 points away from that line of symmetry, we got 3. So if we go 2 points this way, then that would also be at a y value of 3. So now let's just try and draw in this curve here. And it's hard to draw these perfectly, but you can at least get a general idea. And like I said, if you're going to be using this on the Khan Academy exercises, you really just need to find the vertex and then a second point, and it'll fill in the rest of the points for you. So if that's the case, then really you could just pick an x value on either side of the vertex, figure out what its y value is, and then just plot that point. So that's always an option as well. But if you want to be as accurate as possible, you need to find the vertex, the x-intercepts, and the y-intercept. And with all of that, now we have a very accurate graph. Granted, the drawing is not perfect, but it's at least going through all of the correct points.